which I will show you how to use that graphing calculator. I linked the graphing calculator on our Canvas page, and I'll show you how to use that probably at the beginning of class Thursday. But I'm gonna really try to finish out the packet today, not today, tomorrow, so that you'll have, that will give you Thursday, Friday, and then Monday, so to give you 6 class days to get it done, which should be more than enough time for you all to finish it and get it submitted. Start thinking about who you're gonna partner with. If you don't know, I will start picking partners today for your project. You have to work in pairs. We have limited amount of supply, so we don't have enough for people to do it individually. So we have to work with a partner. So if you have a hard time picking that person, I will pick it for you. Okay, let's get started. So let's go to page 3. And we're going to very loosely make a sketch. Keyword is sketch. This is not accurate, but this is just so you can kind of see what each one of these graphs look like. So the first one is a circle. Yesterday we did a circle that was centered at the radius, but when we add in a cosine or sine, it's going to make it swing left, right, up, or down. And it really doesn't look like a circle in my opinion. It looks more like an oval. So if we have a cosine polar, so we have r equals, let's say 3 cosine theta, and then r equals -3 cosine theta. Because of that cosine is going to make it hug the x-axis. So what this is going to say, because this is positive, yes. Oh, okay, thank you so much. Because it's positive, it's going to go out to the third ring. And it's going to go, so about here. And it looks really more so like an oval than it does a circle. So -3 cosine theta is going to swing to the left and look something like that. And again, these are sketches. Not accurate at all. I mean, we're not plotting points, is what I'm trying to say. All right, and then if it doesn't swing left or right, it can swing up or down, which is going to change it from a cosine to a sine, because we know from the unit circle that x is cosine and y is sine. So for an example, if we have r equals +2 sine theta and r equals -2 sine theta. Well, the +2 sine theta is going to go up. And because I picked the 2, I'm only going to hit the second ring this time. It's going to look something like that. The -2 sine theta is going to swing down. All right, so again, these are just examples of 4 different polar graphs. Now, when you're doing your project, you can do a circle as one of your graphs. It can't be a circle like we did yesterday, like r equals 2. That's too easy. But if you wanted to do 4 cosine theta, depending on what design you're trying to create, you can do that. If you look at some of the past projects, the projects have evolved over time, and we'll talk about it. Some people added a circle centered at the radius, but it wasn't one of their graphs. They just wanted the extra circle to be a part of their design type of thing. All right, so now let's talk about the next one, which I don't know if it's pronounced, I think it's Lee Mason, but mathematicians, we call it limicon. Some people call it a limicon, you know, whatever, I don't know. All right, so there are 3 different types, and these 2 numbers will determine what kind of limicon you have based off these 2 numbers. Okay, so the first one, for example, let's say we have, my allergies are acting up. 3 plus, oh wait, let me go back. R equals, I always start with R equals 3 plus 4 cosine theta. Now, because this first number is smaller, it is going to create a graph that has an inner loop. So Oh, sorry. You know, I feel like I gotta sneeze. I hate that feeling. You know, where it's right there, but it don't come out. I hate it. I'm sorry. Okay. So we know it's gonna swing to the right. So it's gonna look something like this. So, and I am not an artist. Please do not judge my artistic ability. Something like that. Do you notice how I have two loops? Like, it looks to me, if I were to describe it in a non-mathy way, it looks like a heart with a loop on the inside. That's kind of what it looks like. And again, you're gonna sketch it out to the best of your ability. Here, let me try to draw that again. So we have an inner loop. And there's a lot of things that determine how far it reaches out to the edge, how far your loop is. But again, we're not talking about that today. We're doing a very, very basic sketch of each one of these graphs. So if we were to make it equal to each other, so for example, R equals, let's say 4 plus 4 cosine theta, what that does is it gets rid of the inner loop. So if you don't want to graph something on the project that has an inner loop, you just need to make these two, make sure that the first number is not smaller. This first number shouldn't be smaller. All right, so now it's just going to look like, and it's called a cardioid. And some people, because cardio, it means heart, because it looks like a heart. So if you want that for one of your projects or one of your graphs on your project, it would just look like a heart, but no more inner loop. So that would get rid of the inner loop. And then thirdly, so there's a lot for these limicons. What if the first number is bigger? So we have R equals 5 plus 4 cosine theta. So this number now is bigger. Then it looks more convex. And that's not even convex enough. Okay, something like that. But it's not as dimpled in the middle. So again, you can pick any graphs and you can kind of play with it. And I'll show you on the online polar grapher how to play with it. Oh, sorry. Can you close my door for me? Thank you so much. I'll show you how to play with it on the polar, so you're not actually doing it by hand. So you're actually going to use the online grapher, pick your graphs, and then transfer that picture to a board. All right. So the next one is a lemniscate. Lemniscate is the only one that begins with R squared instead of R. Okay, so for example, if it is a cosine lemniscate, so let's say we have R squared equals 25 cosine, and this will always be a 2 theta. It kind of looks like a bow tie. Looks something like this. Kind of what a lemniscate looks like. Then it'll be on the horizontal. But if you want on your project for it to not be horizontal, if you want it to be slanted, then you just need to change it to a sine. Because if you change it to a sine, then it becomes slanted. Like that. So depending upon what you want it to look like. And that's your lemniscate. All right, so now let's look at the next page, the last two, we have the roses and the spiral. So for the rose, let's do this first one. If we have r equals, let's say, 4 cosine of 3 theta. This 4 determines the length of the petal. So if you want your rose to go like towards the very edge of your project board, then you just need to play with that first number and adjust it accordingly. So because of that, I know that this rose is going to go out to the 4th ring. Now, as far as the petals on the rose, because this is an odd, so when this number is odd, then that actually equals the petals. So that means I'm going to have 3 petals. So if there's a 3, that means I have 3 petals. If there was a 5 theta, then I would have 5 petals. If there was 7 theta, I would have 7 petals. Okay, so I'm going to actually draw I'm gonna put it here. So I'm going out to the 4th ring. And then I'm gonna try my best to draw there you go. Something like that. Again, we're just doing sketches, not perfect. But if you don't want 3, then we need to flip that number. If we don't want an odd number of petals, we need to flip it to an even number. But when we do that, there's a trick, or there's a kind of a little thing about it. So if I were to change this, let's say I said r equals 4 sine of 4 theta. Nope, I don't want to do 4. That's too much. Let's say, let's do 2 theta. All right, 2 theta. The reason why I was hesitant is because instead of it being the same, if it's even, the petals double. So you know how when the last example, it was 3, so we had 3 petals. Well, now we got to take that number and multiply it by 2. That's how many petals we're going to have. So because that's a 2 theta, how many petals am I going to have on my rose? 4. If I had to make that a 4, then I would have had to draw 8. If I made that a 6, then I would have 12. Okay. So it can very quickly get pretty big with how many petals you want. So if I'm going to draw 4 petals that go out to the 4th ring, which is kind of easy to do. So I'm going to just do that real quick. So again, what I recommend, because again, the boards and things are expensive-ish, I want you all to maybe spend a day planning your design before you actually start to try to transfer that design to the board. All right, and the last one is the spiral. Yes.
The second one, would the board have to be like on the axes, or can it be like?
So it just means that it's going to go out to the 4th ring. So it's going to, the longest edge of that petal.
So like, can the petals like not like can you like rotate the flower over?
Oh yeah. Okay. Yeah. And that's going to change depending on sine or cosine. And we can talk about that probably tomorrow. We'll graph a rose. Roses are the hardest to graph by hand. But again, you won't have to graph these by hand. I'm going to show you how to do it on an online calculator. I don't have enough of the handheld calculators, but honestly, I do prefer using the online calculator because it's a little bit more user friendly. So we'll just do that. All right, so the last one is our spiral. Spiral is the only one that doesn't have a sine or a cosine in the equation. So notice that in this equation, we have no sine or cosine. It's just going to be radius equals something with theta. Okay? And it's actually the easiest to graph because it's literally what it sounds like. It's a spiral. And we're going to talk about how you can make it swing different directions today. So again, I'm not graphing anything. We are going to graph a spiral today. We're going to graph a spiral, a circle, and a limicon today. Is that thunder?
Yes, I just got back in from.
That sounds bad. That sounds pretty bad. Okay, guys. So on your final, this is what it's going to look like on the final. On the final, you will be given a equation, and you're going to have to tell me what kind of graph it is. So I'm going to write our 5 different types of graphs. We have a circle. We have a limicon. We have a lemniscate. We have a rose, and we have a spiral. Let's go ahead and match these up. So what would you say this first one is? Number 1. Lemniscate, because it's the only one with the R squared. So this first one, if this was on the final, you would say, oh, that's a lemniscate. It's multiple choice. So you would pick A or B or C, whichever one says lemniscate. Do we have any other lemniscates? Any other R squareds? All right, the other one that is pretty easy to identify, in my opinion, is a spiral.
Number 2.
So spirals don't have sine or cosine in the equation. So which 2? Number 2 and 5. So I agree. These 2 I know are spirals. So I took care of this. Okay. The only one that has a plus minus, that's dangerous, y'all. Plus minus and a cosine is a limicon. So which numbers do we think are limicons? 4 and 9. Now for a circle, this is the only one. Let me go back and explain that too. Notice that for the circle, this is the only one that's just like a number cosine of 1 theta. For a circle, we're not going to multiply theta by anything. So if theta is just multiplied by 1, and then there's a sine or cosine with no plus or minus, that's a circle. So it's kind of the pattern to kind of look for. So I see 2 circles. Which numbers are we going to call circles? 6 and 8. And that means that we're left with our roses. Both of these just happen to be odd numbers. So this will be a rose with 3 petals that reaches out to the 2nd ring. This is a rose with 3 petals that reaches to the 3rd ring. All right, any questions or comments about that? So for our tables, for our projects, it has to be in radians. In the past, I did allow degrees. I'm not doing that anymore. If you would like to do it in degrees, you automatically lose 10%. But it's really not that hard to do it in radians. So does everyone have a yellow calculator on your desk? The first thing we're going to do is change our calculator to radians. So because it's the 2nd period, I think 1st period already changed it, but let's make sure. So on your calculator, I want you to hit that button at the top that says mode. And do you see at the top, you have degree, radians, graduated radians. We're not going to use that one. It's either going to be degrees or radians. Make sure that radians is highlighted black. Okay, if it is, great. If it's not, you simply want to arrow over, hit enter. Change your graph, your mode to radians. All right, I think I'm in radians. I don't know. Okay, so that's that. So now that we have that, let's go ahead and start building our table. So let's graph go to page 5. Let's go ahead and graph a number 1. What kind of polar graph do we have here? Circle. What direction is this circle going to go? Left, right, up, or down? Left. And I just like to put that there so I know in my mind what it should look like. Because if it's not looking like that, I know I messed up. All right, so the good thing about it too is it's going to reflect. Let's go ahead and fill in our thetas. So let's do 0, pi over 6. Okay. Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4. So I just did the first 2 quadrants. So in your calculator, let's go ahead and I'm going to show you how to type it in. But when you type it in, I have -2 and then cosine 0. Hit enter. You should have -2, so that's your first radius. And then -2 cosine pi over 6. So pi divided by 6. Hit enter. We're going to just go to the tens place because we're graphing this by hand. When you get that, that's the exact answer. Remember to change it to a decimal, you hit the button above enter. So this number at the very bottom, the button at the bottom with the 2 triangles going left and right, hit that button, that changes it to a decimal. So we're just going to say it's -1.7. I'm going to type in one more and then let you all finish the rest. -2 cosine pi over 4, pi over 4. There's a little bit of lag on my computer, so that's why I'm going a little slower. -1.4. So when you're filling that in, go ahead and fill in your chart. Well, because I'm doing it by hand, I can't really graph accurately to the hundredths place, right? We can probably barely graph it right to the 10th place. So the 10th place is fine. Now on your project, I'll probably say to the thousandths. I have to look at what I did last year or the rubric. So take a minute and fill in your chart. And then start to graph it based off what we learned yesterday. And now keep in mind that it is not going to be perfect. It may not be pretty. That's okay. Do the very best you can. And a lot of these points might overlap. Like, for example, I know that this point is the same as this point. It's going to be the same. 0, -2 is the same thing as pi 2. All right, so go ahead, take a minute, graph your points, and then we will look at our design. Again, don't worry about perfection. I just want you to get an idea of what it should look like. And as I'm graphing it, I know that it's going to reflect across the x-axis. So when I'm plotting a point, I know that if I have a point here, I'm going to have one right here because it's symmetrical across this x-axis. So I'll give you a minute to finish out that graph to the very best of your ability. And then we'll start working on number 2. For this next one, I'm just gonna I'm gonna give you your points because we don't have time to actually, for me to wait for you all to do these individually. Does anyone need more time with number one? All right, so go ahead and start filling in your chart for number two. And then I'm gonna give you all of the points. So fill in your chart, and then I want you to try to graph them. Oh, before I continue though, let me pause. What kind of graph is this one? Limicon. Is it a cardioid, convex, or is it, does it have an inner loop? So you're looking at these two numbers right here. If this number, this is A, this is B. If the first number is smaller, it's going to have an inner loop. So we have a Lie Mason with an inner loop. That's what it should look like. So it's to your advantage to know what it should be, what it should look like. So when you're doing it, if it's not looking their way, you know, either you need to add more points, you need to adjust accordingly. That's a pi over 3, by the way. Let me fix that. All right, I'm going to give you these values and give you a minute to graph them to the best of your ability. Okay, and that might be too many points. I don't know. So I'll give you a minute to kind of graph it out, and you know what it should look like. You should have a Lie Mason with an inner loop. I have to really like pay attention closely when I'm doing these myself. Okay, so then we have pi over 4. Or let me start over. So I'm plotting my points. So I have 0, 1, pi over 6, 0, pi over 4.
I thought sound was up.
I'm so sorry, excuse me.
I thought sound was up and down.
Yeah, it is gonna be when you plot all your points. Yep. All right, so I'm plotting my points here. So pi over 4, that's like negative 0.4. Pi over 3, we get a little bit closer to 1. And then we're at the 0. So I can see how I'm kind of, you see I'm forming this inner loop right here. It is forming right there. That's my little inner loop. And then, let's see here. We got pi over 2. That's negative 1. And then we have 2 pi over 3. And then we have 5 pi over 6. So 5 pi over 6 is 0. And pi is 1. 7 pi over 6 is 2. Kind of forming that loop there. And then I know here is 3. 1, 2, 3. And then I know that the right side of that graph is going to be a reflection of the left side. So I kind of just go off of reflecting. So I'm just going to reflect this point over here. Again, we're not looking for perfection. Perfection is for the brain surgeons. We're not brain surgeons, so we're good. We're good here. All right, and the last one we're gonna work through today is a spiral. So I'll give you a minute to finish this one out. Anybody need more time on number 2? So this is a spiral. And I do think these are my favorites to graph, honestly, because you're just typing it in the calculator. So, for the spiral, we'll just pick a few points. So let's do 0, pi over 4, pi over 2. I think, yeah, I just did the 45s. That's what I did. My little raggedy little stylus pen is really trying to die. But I'm not going to replace it because it's only 12 days of school. It's just going to have to rough it out. Don't want to write no more. Okay, so how do we type these in our calculators? Just the way it looks like. So for the first one, if you type in -0, -0 is 0. So we don't need to type that in our calculator. So now let's go back and type in -pi over 4. So you're literally just typing that in. Let me clear this out. -pi over 4. And we're going to go to the 10th place. So that would be about -0.8. And then we have our next one. -pi over 2. -1.6. So take a couple minutes and fill in the rest. All right, who had those numbers in their table? So they're all negatives, which means we're going to go backwards. So we're going to start off at 0. 0 is 0. And then at pi over 4, -0.8, I'm going to go backwards. It's going to land right almost at the 1, but not quite. So I'm going this way, my spiral. And then my next one, pi over 2. Oh, wait a minute. Am I going that way? Oh, yeah, I'm going that way. All right, so then next one we have pi over 2. Pi over 2 is right here. My allergies are really acting up. So pi over 2 is right here, but it's negative, so we're going to go back. Here, let me not connect these points yet, because that don't look right. Hold on. Oh, okay, yeah, I was going the wrong way. All right, so connect the first 3. Plot the first 3 before you try to connect it, because I was about to draw my spiral the wrong direction. All right, so pi over 2 is here, so we're going to go backwards. So 1.6, negative 1.6 is almost at the 2, but not quite. Now I can see that the spiral is going this way. All right, and then we have 3 pi over 4. 3 pi over 4 is right here, but it's negative 2.4. So I'm going to go backwards, 1, 2. So right in between that second and third ring, we're going to put a point. And then at pi, right at that third ring, we're going to put our point. And then 3 pi over 2 is almost at the 5th ring. 1, 2, 3, 4, 5. So it really doesn't take a lot of points. And it keeps going now. But that would be your spiral. Here, let me trace it and make it a little thicker. So you can do a spiral. Spiral is the only one that, I mean, obviously you're going to have to make an endpoint to it because you can't graph them all. All right, we are not going to graph number 4 because that's a circle. We've already talked about a circle. We're going to move on from circles. We are going to graph number 5 tomorrow. That's a lemniscate. We're not doing number 6. So tomorrow in class, I'm going to graph 5, 7, and 8. And then if there's time, I will give you a chance to play on that online graphing calculator.